So the new chapter that we're about to start is called Linear Graphs, and within the first unit of that is interpreting line graphs. Okay, so for this topic here, these might be some of the questions that you'll come across. Selena leaves home to go for a walk. The following line graph shows her distance from home. So for this question here, it asks us to describe what's happening in section A, B and D. So if I have a quick look, section A, you can see here that she's obviously getting away from home. I would say that she's travelling at a constant pace because the line's going continuously. If I look at section B here, is actually a flat line, which tells me her distance isn't getting any further, like going up that way, and it isn't getting any closer to back to home. So for there, I would say that she is stationary somewhere. Section D was the last one that we're asked to look at. You can see there that she's obviously turned and come back home because she gets to a distance from home of 0, and she's probably running because it's pretty quick. If we just have a quick look at section C, what I'd say is happening is she's getting further away from home. As you can see, the line increases upwards, but she's probably going slower than section A because the line actually isn't as steep, so the time's a lot further out for the distance that she covers. Okay, so this question here asks us in which section is Selena walking the fastest. So what we want to do is, it's probably easier if we break it up into these little sections here, because that's going to tell us on the baseline roughly how much time it's taken per thing. So first of all, if I look at section A, you can see here this is how long it's taken, and she's travelling approximately 1 kilometre, judging by where it would intersect the distance from home axes. If I look at section C, she's obviously continued from here up to here, so again walked about 1 kilometre, but you can see this here, time-wise, is a lot longer than section A, so we can count out section C as being the quickest because there's too much time. If I look at D, it tells me here roughly the time frame for section A and D is about the same, but the distance she covers, in D I'm going from 2 metres or 2 kilometres back to home, whereas A she only travels 1 kilometre in that time. So for me, my answer for that one would be that in section D, that is where she's travelled the fastest. So if we look at what happened in the previous one about how quick she was, now we're looking at in which section is she travelling the slowest. So from the previous one, we actually had worked out that in section A she'd covered about 1 kilometre over that time frame there, and in section D she'd travelled 2 kilometres over that time frame. If I look at section C, she's obviously travelled 1 kilometre up, or 1 kilometre away from home, but the time frame's a lot longer than A and a lot longer than D. So for me, the answer to this one is going to be section C, she's walking the slowest. Okay, so this one here is pretty straightforward for us to work out. So what this line tells us that for her to get to point section there, she has travelled 2 kilometres. Then obviously she has to walk back home because it says we get to a point back here. So to get back home, she's obviously travelled another 2 kilometres. So if I add both of them together, it tells me that she has travelled 4 kilometres in total. So this here is the final slide for our interpreting line graphs, and this one's actually a speed versus time graph. So to make things a little bit easier for us to follow, I'm just going to put made up speeds down on the axes just so we can have a bit of an understanding. So that's meant to be 50, 75, 100. Okay, so if I look at section A here, what's happening there is starting at 0, increasing up to a constant or to a speed there, and so I can say what's happened there is I've accelerated. For section B, however, what's happened here is I haven't got any faster, but I haven't got any slower. So what's happening is I'm travelling at a constant speed. Section C is the same as section A, so I've obviously accelerated again because I've gone from that constant speed of, according to my rough guess, about 50, up to another constant speed, and according to this one, about 100. So that one there is accelerating. If I quickly look at section D, obviously again I'm travelling at a constant speed because I'm not getting faster, I'm not getting slower. Now if I look at section E, what's happened here, obviously I'm travelling at a constant speed up here, and then I've had a sudden stop, because then I've got back down to 0 speed. So what I can conclude is happening in section E is that I'm actually braking. So hopefully that makes a bit of sense now, that the section A we've accelerated, travelled again at a constant speed, accelerated, travelled at constant speed, and then we've braked to finish. And that's the end of our topic. Thank you.